official nerd business.
Hello nerd boys and girls, and welcome back to our programming series. It's been a while. I have personally been very busy and the office has been an absolute quite busy too. So I haven't had time to record any of these, and well, we're gonna get back into it. As I said previously, this is number 40. I've been doing this YouTube channel for about a year now. So both occasions make me want to do something special. Unfortunately, this particular Euler problem is lame. Not really great. So let's run through it. As you can see, I already made our Project Euler template file with our defined methods for the attempt number 1, for running it on its own if we were to execute this file, or to run it as with this entry point if we were to run it through the main py that we have for Project Euler. And up top is the description of the problem. It's Champernowne's constant. An irrational decimal fraction is created by concatenating the positive integers. So we have 1 concatenated to 2, concatenated to 3, etc. Concatenated to 10, concatenated to 11. So basically this is Champernowne's number, or constant, and basically what he said was, nah, let's mess around a bit. I'm gonna simply glue every rational whole number onto itself, and I keep on going in this infinite fashion. So there is an irrational number in more senses than just the 1, I guess. So it can be seen that the 12th digit of the fractional part is a 1. Unfortunately, that is somewhere in here. So which one that is, if it's 0 indexed or 1 indexed, is left as an exercise for the readers. And if dn represents the nth digit of the fractional part, find the value of the following expression, d1, so the first digit, which is this one obviously, times d10, times d100, times d1000, etc. all the way up to 1 million. So let's get to that. Instead of having for our default value, instead of having a list of all of these values, I'm just gonna derive them from this one out. I'm just gonna divide by 10 all the way until I'm at 1 again. So we have one input parameter here, which is just significant digit, which is simply the highest, and we're gonna get the rest by division. So let's get to it. I'm gonna make this attempt. I'm gonna make one attempt also, because this problem, it really doesn't have a very interesting angle to get at it from another way. Trust me, I've looked. I haven't found anything. I couldn't think of anything myself. I haven't found anybody else on the internet tackling this in a creative manner. So we're just gonna stick with what works. Funny thing about Python, and maybe that's the problem here, is that when this problem was drafted, programming languages were more limited. But constructing a string of 1 million characters long is absolutely no problem for Python whatsoever, as we're gonna see in a bit. So we're just gonna stick with that. So we will need all of the digits in which we are interested. So I'm gonna create a list of digits, and I'm gonna throw in the limit that we already have here. This is going to be the first item on our in our list, and then I'm gonna say not for but while our limit is not 1. I want to divide this limit by 10. And I want to add to to our list of digits, our digits of interest. We're gonna append to that the new limit. Also, this division will, in fact, let's show it. Print we are going to print out the digits once we're done in here, simply as a debug statement, and I'm going to run this file on its own. Hang on, I made a typo there. Yes, there we go. As you can see, it converted all of our numbers to floats, to decimals, with a 0 fractional part. But they are all decimals, and we are going to use this as an array index, and those can only be ints. So to mitigate that, I can just simply put a cast here to convert them to int. And if I run this, then that problem is sorted. Alright, that's hindrance number 1. Now we need to build up our Champernowne constant. So here you go, champ. This string is going to start out with the leading 0. We're going to forget about the decimal point, but we are going to add all the fractional parts. We're going to glue them all straight onto this. And we need a counter variable just to start off at 1, because what we're going to do now, while our length of our champ is less than the maximum number or equal, we do want to contain our upper bound here. Now our digits have all of the digits that are of significance to us. So as long as our string doesn't at least have that many digits, keep on repeating this process where you have your Champernowne constant as a string. It's really not very interesting as a number here, since we are just gluing on one integer after another. It's more of a string computation than an integer one, really. So we have our string here, and we're going to append to it the string representation of whatever our current counter variable is, and we are going to increase that. So at first run this will be a 1, then a 2, then a 3, then a 4, then a 5, etc. until the string is exceptionally long, over 1,000,000 characters in length. In fact, I'm not going to print the string itself, but I can print out the length of the Champernowne string. So what does this button do? We've created a string that is slightly above, and in fact let's check out at what integer this cut out. Yes, this was the, so 185,186 was the last digit to be added to Champernowne's constant. So if we were to print the last 10 characters, then these would make up the tail. And that gives us a string of 1,000,006 characters long, so that's long enough for what we're about to do with it. Now we want to take out digit number 1 and digit number 10 and digit number 100 and multiply them all over. So I'm going to start with P for product. This is going to be a 1, since we're multiplying things into this. A 1 is a safe starting value. And then we're going to say for D in digits. We're going to take every digit from our list, and we're going to get them from our constant here, and this is going to be a string multiplied by an integer, and that's not going to work, so we are going to cast whatever string character we get from here. We're going to cast this into int, and then we're going to return a result. So if we run this on its own, we get this answer. And this is the correct answer. If you go over to Project Euler and you enter this number as the solution for problem number 40, you will get the green check. As said before, unfortunately it's not a very entertaining problem, but hey, you have those too. So here you go, this is our solution for Euler problem number 40, and I will see you again next time for 41.
Thanks for watching this video on Official Nerd Business. Don't forget to like and subscribe and click the bell icon. Did we discuss everything you wanted to hear, or did we miss anything? Any topics you want to hear in O&B? Leave your thoughts in the comments. See you next time.